Welcome, everyone. Thank you so much for joining us. This is GRC301, Best Practices for Managing Governance, Risk, and Compliance Globally. So my name is Nivas Dureraj. I'm part of our cloud governance team, and we support our services like Control Tower, Organizations, and Config. I'm joined by Aaron Koo, who is the leader for AWS Control Tower, and that's our secure landing zone service for customers, and Akash Grover, who is one of our lead production engineers for Meta. Just to highlight why GRC is so important to organizations. We're starting to see more and more workloads being moved to the cloud. And in the past, it would be test workloads, which meant that GRC could be possibly optional. Now, no more. It's a must for organizations. And this stat sometimes surprises a few folks. The cost of non-compliance can be higher than maintaining compliance in cloud environments. And so if we were to implement GRC properly, then organizations would experience fewer security incidents as well as benefit from cost optimizations. So hopefully this gives you an idea of why GRC is so critical to organizations. But there are challenges in implementing governance, risk, and compliance. A lot of our customers are always dealing with new or updated regulatory environments. This is changing across geographies, it's changing across industries. We see it in healthcare, we see it in public sector, we see it in financial sector. Your environment has to be able to adapt to all of these changes. And this means your tools, your processes, and rules. And then data. Data usage is increasing across all of our customers. More customers, organizations are exploring generative AI, ML AI workloads, analytics, and so on. So data is becoming incredibly more valuable, but then at the same time, we have to consider data privacy, sovereignty, and its resiliency and protection. And with all of this other challenge is you also have to balance your cost versus the risk management solutions that you implement across your environment. So that's what we're going to talk about today. We're going to talk about how you can implement GRC across your environments globally. And so our agenda for today is I'll first talk a little bit about the people and process aspects because it has a huge impact on GRC's effectiveness across your multi-account environment. Akash will share how Meta thinks about governance and how Meta implements governance within their multi-account environment. Aaron will talk to us about how to implement a control strategy, the different types of controls, and how you can set it up in a multi-account environment. And finally, I'll round it off by talking about data resilience at scale. So the people and process. This is quite basic, but I think it's incredibly critical. And it applies to a lot of initiatives, not just GRC, but start with your why. And it means aligning with your business objectives. So for example, you might be an organization that is building a mobile application that has a payment processing system. That means you're dealing with PCI or personal credit card information or PII data, but that means that you will have to meet certain kinds of regulatory financial frameworks, security standards, and so on. And then the data itself has to be governed, it has to be protected, and you may also want to consider who has access to this kind of sensitive data sets. And you can take this further when you think about who is using these data sets. Example, redacting certain fields and phrases. And this is all about managing the risk and ensuring compliance. Second, assess your existing processes. We're not saying that you need to start from scratch. You probably already are implementing GRC processes rules within your existing organization. But understand where you are in this journey. And here we have a few types of questions that you can ask yourselves to figure out what you have currently running, what's existing, and then consider how you can improve upon them. It's not meant to be revolutionary. We're trying to evolve your existing processes. And third, this is a strong recommendation: align with your stakeholders. You have leaders who are going to play a key role in implementing the GRC program and its initiatives across your organization. They have to understand why GRC policies are so critical and how it can help them make better decisions for the organization. And then your teams. Your teams may consist of hundreds to thousands of development teams. These teams are dealing with individual applications. These applications will have different components, different resources, different resource configurations, different data sets. Some might be public, some might be private. These applications are going to require and have a different set of compliance requirements. And so that means your individual teams, your development teams, also have to be well aware of the governance, risk, and compliance requirements, as well as the organizations. And so hopefully this gives you a good idea of why the people and process aspects are so critical to implementing GRC. And with that, I'm going to invite Akansh to talk to us about Meta's governance story.
Hello, everyone. Thank you, Nivas. My name is Akansh Grover. I work in Meta's Cloud Foundation team. At Meta, we serve 4 billion monthly active users, 3 billion daily active users. At our scale, we provide services to people across the globe. We have to comply with the standards across the globe. This is the primary reason why building a robust GRC story is very important for us. You might know, at Meta, we own our own data centers. We run our own data centers. We have one of the largest infrastructure backbone in the world. Our own infra enables us to provide services at a massive scale reliably to our users. However, we still leverage AWS for our infra needs. Some factors which make us use AWS, latency. Sometimes you want to be closer to your end user. Experimentation. AWS has a lot of services, more than 200 services. Some of these services help our developers do POCs, move fast, build features for our users, specialized capabilities. So sometimes we don't have the right type of compute, right type of services within our data centers, so we'll leverage AWS to fulfill that gap. Compliance, like I mentioned before, we run our services across the world, so we have to comply with standards across the world. Some of these standards are very strict, based on geolocation laws and things like that, so AWS fills those gaps for us too. At this point, we have more than 1,000 AWS accounts, growing every day, serving different needs, serving different compliance use cases, and things like that. Cloud compliance in Meta starts before any part of the infra is deployed. We make sure every use case which goes to cloud, goes through different reviews related to finance, privacy, legal, network security, third-party access, things like that. Some of these are very obvious. Finance, because we want to have strict budget controls. Third-party access, if a use case is going to work with a third party, we want them to go through third-party reviews to make sure we're not sharing data with a vulnerable partner or something like that. Privacy reviews, at our scale, we need to do privacy reviews so every developer team understands the privacy requirements. Deletion control, for similar reasons. We don't want to hold on to user data for more time than we have to. These reviews help us gain visibility into our use cases even before we let anything being deployed in cloud. And this lets us get ahead of the problem in long run. In Meta, we use AWS for very different workloads. All of these workloads are very different from each other. Some of them are really large HPC clusters. Some of them are really small third-party use cases. At our scale, we need to logically group these accounts, AWS accounts, apply codified policies to manage our requirements, to manage our compliance. AWS organization is the way we have went forward to codify these policies. As you can see, this is a very high-level simplified diagram of our organization tree in Meta. This lets us group accounts logically according to their use case. The structure enables us to scale, deploy preventive controls reliably, and it just lets us scale and work at our level. Some special use cases which are enabled via this structure, incident response. So if we notice a malicious event in a certain account, we can move that account to our incident response OU, lock it down. So threat engineers, threat detection people can go in, investigate the problem. DMZ is our experimentation OU. This is the only part of our organization tree where we allow root to be used, for example. So it serves very, very different use cases, but that's the way we removed usage of root, but still have a way to get back as root if we need to. Sandbox is very special. That lets us create ephemeral accounts with higher controls, or actually low controls, but some restrictions. If an account is created in Sandbox, we make sure it's gone within 2 weeks. This allows us to enable our developers to do experimentation, move fast, do POCs and things like that. Some of the other guardrails which we have codified are something like service gating. Service gating is our special compliance thing. This makes sure we don't let use cases use resources to store data which they are not explicitly approved for. For example, if your use case should not be using S3, we won't let you use S3. This is done via SCPs. We create dynamic SCPs based on your use case. We have selected 45 services which are critical to us. Based on your use case, we'll generate an SCP for your account. We do make sure we don't run into SCP limits by doing dedupe, hashing, and all those other algorithms we can use. This lets us comply with some special requirements on our side. We are very serious about infrastructure as code. We have also codified policies for infrastructure as code. This makes sure every part of our infrastructure is managed by Terraform. This enables us to build controls into Terraform. This lets us build more compliance controls into CI/CD pipelines and things like that. We use RCPs. RCP is a new feature. This was released by Amazon last year. We have already started using it to create data parameters around our sensitive workloads. We keep going to build more RCPs, keep going to build more data parameters, but we've already codified some of these policies. One issue you might be thinking, if you have some experience with SCPs or RCPs, you might be thinking about is bad user experience. With all these policies, user will get access denied messages. And one feature which SCPs, in my opinion, lack is dynamic error messaging for every error. The way we solve this, or we try to solve this, is by looking at tailing CloudTrail for all these errors. If we see an access denied because of one of our codified policies, we'll immediately let the user know why their API call failed, what we want them to do. If they're trying to create an S3 bucket in console, we'll block them. We'll tell them how we want them to create an S3 bucket, for example, and things like that. This helps us keep the user experience sane. This is a very simplified diagram, how this works. We consume CloudTrail from all the accounts. We filter out all the access denied messages. And we have our custom binary, which keeps tailing these messages and notifying users about these errors and these problems. This lets us build more codified policies while keeping the user experience manageable. I've said it before, but infrastructure as code is very important for us. We strive to make sure 100% of our code is deployed via Terraform. My team provides a CLI called Cloud CLI to our customers, to our developers within Meta. Cloud CLI is a wrapper around Terraform. It has integrations with internal systems, internal CI/CD pipelines, and things like that. So we want everyone to use Terraform. We want everyone to write Terraform to manage their infrastructure. This makes all the changes go through code reviews, which is a requirement for us. This also lets us build small, secure by default building blocks. What do I mean by that? If we notice a lot of people using S3, we'll write a module for it, abstract all the security controls in the module, and we'll ask users to use our module. The thinking behind it is, if you use our module, you're always secure by default. You're doing the right thing as per the data you're storing in your S3 bucket. We can abstract the encryption control, access controls, and all that. And users don't have to figure that out all the time. It just takes care of all the problems for you. We have followed the same process in EC2, EKS, VPCs, and other modules. If we see some resource being utilized a lot in our infrastructure, we will write a module for it. We will try to abstract all the security controls for it. What it enables, you as a developer, you can pick one of our smaller building block, integrate this with your infrastructure, and build a larger piece of infrastructure within your account. You're choosing all these secure by default building blocks, and our hope is your larger part of your infrastructure will be secure by default. We have also integrations for TF-Lints, TF-Comply. These are both open source projects. We use Rego rules to detect problems in your code, making sure we can warn you, we can block you from deploying dangerous configurations. This helps us shift left and stop you from making dangerous configuration changes in AWS. This is the high-level setup we use to create visibility into our AWS environment. This lets us consume, as you can see, this lets us consume logs from AWS managed services like config, GuardDuty, CloudTrail, CloudWatch. If there's an AWS managed service, we'll consume the logs in the similar way. We'll aggregate these logs into an S3 bucket, integrate this with SQS, and just start bringing these logs back to Meta so that we can analyze them better, so we can store them better. This has helped us scale our AWS adoption in the last 5 years. It's the same model we use to bring billions of logs every day back to Meta and store them long-term to satisfy our compliance requirements, to do security analysis, to do more analytics, to take more data-centric decisions on our infrastructure. I want to especially shout out to AWS Config. AWS Config we use to we collect snapshots from AWS Config across all the accounts, all the regions which we operate in. We consume these snapshots, bring them back. This has helped us take a lot of data-centric decisions. For example, AWS Config can tell you which resource is being utilized by your team most, and this helps us figure out which resource we should write a module for, and things like that. This also helps other downstream teams like capacity management, finance, even cloud users trying to deploy stuff in their account, evaluate their own infra, take better decisions, and things like that. And same goes for Wiz. Wiz is a third-party integration we have recently built. We use Wiz sensors on our compute. We use Wiz Outpost. And this helps our security teams triage security incidents, keep an eye on our infra all the time, keep the security incidents manageable. And this has enabled us to deliver security at scale. As Nivas pointed out earlier, you need to figure out your GRC goals before you build a GRC story. At Meta, we think visibility, monitoring, and prevention are our top-level goals for GRC. AWS, as a provider, will provide multiple paths, multiple options for you to hit these goals. But there are so many ways you can build a story around this. You can do everything using managed AWS service, or you can build your own thing. End of the day, this is going to be a choice of the team managing your infra. And with that, I'm going to hand it over to Aaron to talk about control strategies you can adopt in AWS.
Good afternoon. As Nivas introduced earlier, my name is Aaron Koo. I am the Senior Manager for AWS Control Tower. I want to start by thanking everybody for being here on the last day of Inforce for the absolutely riveting topic of GRC. Hope I'm able to carry your wakefulness until the end of the hour. The cornerstone of a governance, risk, and compliance strategy has to be a comprehensive set of controls that help you audit your applications and resources for adherence to those policies, or even better, guarantee that those policies are not violated in the first place. We're going to start by taking a look at the GRC challenges, reviewing the GRC challenges that Nivas put up earlier. Data sovereignty for regulatory reasons is usually top of many enterprises' lists of concerns. You also have data perimeter for access control and data resiliency or protection, particularly from ransomware. Beyond just security, you also tell us that in many cases, operational concerns such as application availability and cost management also form part of the GRC objectives in your organizations. Before I dive into the governance controls proper, I want to call out that AWS actually provides a very extensive list of services that you can use to help manage your GRC objectives. So, for example, GuardDuty provides intelligent threat detection through AI. CloudTrail, of course, I'm sure most of you are familiar with. You can use it to audit your the API actions that happen within your AWS environment. And Audit Manager collects evidence that can be used for compliance assessments. You can enable these services individually or in whatever combination makes sense for your needs. Obviously, there are way too many of these to go through in a deep dive at a session like this, but we encourage you to have immersion days for any services that you might be interested in. Governance controls encapsulate GRC policies. They are a tool that can be used to either prevent a violation from happening or audit that a violation has not occurred. There are three categories of such controls. Preventive controls will prevent policy violations through hard enforcement. They are designed such that users cannot create resources that would violate the policy in the first place, or are prevented from updating resources in a way that would cause the policy to be violated. Preventive controls are particularly useful for central IT administrators or security teams to use in a way that enforces a blanket policy across the entire organization. On the other hand, proactive controls are designed to scan the configurations of resources within a deployment or provisioning pipeline such as Terraform or CloudFormation. Earlier you heard Akansh talk about how Meta uses Terraform, and they have a set of such controls in the pipeline to validate that any resources being deployed adhere to the policies. And a little later I'll show an example of how you can do a similar thing in a CloudFormation pipeline. Finally, detective controls are designed to audit the environment or applications and resources to make sure that they don't violate the policies. These controls do not perform any sort of blocking action, so they are always safe to enable. They're just there to scan existing resources for any violations. Detective controls are useful for compliance officers or auditors who might want a report to show that no such policy violations have occurred in the environment. They are often also used as a secondary line of defense together with preventive or proactive controls at the same time. Let's deep dive into each of these control types, starting with preventive controls. Preventive controls are implemented as AWS organizations' policies. They disallow any actions defined in them from being taken, and they often are used to enforce these absolute boundaries in your AWS usage. There are three types of such organization policies: service control policies, or SCPs, resource control policies, or RCPs, and declarative policies. RCPs and declarative policies are relatively new. SCPs are designed to set the maximum allowed permissions for identities or principals within your organization. You can prevent or restrict identities from performing any API actions that you deem never allowable, or restrict those actions to a limited set of individuals, for example, a security team. RCPs, on the other hand, control the maximum allowed API actions that can be performed on a resource. So these are often used for data perimeter scenarios, as we will see in an example. And finally, declarative policies are used where you can define a specific configuration for an attribute for a resource within an AWS service. Once you've declared this configuration in a specific way, AWS takes care of ensuring that all resources of this type within the organization will absolutely have this configuration value. So it cannot be overridden. Let's start by taking a look at some SCP examples. SCPs are similar to IAM policies, but they don't grant any permissions. Rather, they specify the maximum allowable permissions. You can attach these policies to an organization root, organization unit, or at account level. If you attach them to an organization root or OU, we take care of ensuring that all the member accounts that are under that hierarchy also inherit the policy. So let's take a look at some specific examples, starting with one of our favorites, which is a data sovereignty one. This particular policy will ensure that services and resources are limited to a specific AWS region, in this particular case, AP Southeast 2. Another example is a policy that limits the usage of EC2 instances to a specific EC2 instance type, T2 micros in this case. And such policies can be used for either application availability concerns or cost management concerns. Another example is a security one, unsurprisingly. you can use a policy to deny certain APIs from being used or being called for security or logging or networking services to make sure that nobody changes any settings either accidentally or maliciously. Another common policy example is the limitation of the creation of new IAM users or access key creations. These examples are available in a repository that is publicly available. We will provide a link to that repository at the end of the presentation so you can take a look at it, use the examples either as inspiration or directly in your own environments. Now let's take a look at some RCP examples. Remember that RCPs define the maximum allowable API actions on resources. First, this is a policy that will restrict actions that are taken on a set of resources to be from identities or users within my own organization only. You cannot, an actor from external to the organization cannot take any API actions on those resources. Similarly, this particular policy defines a networking perimeter where any API actions have to be initiated from within the corporate network or VPC. And these two examples, of course, are, again, data perimeter examples, which are often a GRC concern. So RCPs and SCPs are two different types of controls. It is not an either or. You can always use them in conjunction with each other. SCPs operate over principals, RCPs operate over resources, as I've said, and it is often easier to express your objectives in one or the other, depending on what you're trying to do, so you should use the appropriate control type in your environment. Earlier, again, you heard Akansh talk about how Meta actually uses both RCPs and SCPs in their environment. There are some use cases, additional use case examples I've got on there, but I'm not going to go through them one by one and put you to sleep there. So I'll give you a specific example. The top half of the slide is an RCP, which defines a data perimeter around resources within your environment, the same policy we saw earlier, such that only users from within your corporate environment can access resources within that organization. External actors cannot do so. The bottom half of the slide shows an SCP, which restricts those same corporate users from accessing resources outside the organizational boundary. So working in conjunction, you have a very clearly defined boundary around the data that you care about. Let's talk about declarative policies. Remember, these are policies that can define specific configuration values for an AWS service. Currently, declarative policies are only supported for the EC2 suite of services, which include EBS and VPCs. For the purposes of this particular example, let's say I want to ensure that my EBS snapshots can never be shared publicly, and this includes both existing and future snapshots. To do this, I would define a declarative policy and attach that policy to an organizational unit within my organization. Once attached, the policy is inherited by all member accounts within that organizational unit, and the EC2 control plane, respecting the declarative policy, will ensure that all snapshots within both the accounts and all regions will be governed by this policy, and the attribute will be configured to block all sharing. Next, let's take a look at proactive controls. Reminder, proactive controls are used to ensure that no incorrectly configured resources are deployed through a provisioning system. CloudFormation defines has a feature called CloudFormation hooks. These hooks can be attached to your CloudFormation pipeline to validate any resources, the configurations of any resources that are being deployed through the pipeline. In this case, let's start with a simple template that creates an S3 bucket. The S3 bucket has no attributes attached to it. Now, as part of my CloudFormation pipeline, I have a set of CloudFormation hooks attached to it. One of the hooks happens to validate that any S3 buckets being deployed through the provisioning pipeline has to be encrypted. So when I try to deploy this particular template, the hook will execute and it will cause a failure to be generated because there is no encryption defined on this S3 bucket. It will cause a rollback of the deployment, and the application developer will get an appropriate error message, and they have a chance to remedy the template before attempting the deployment again. CloudFormation hooks can be defined in a number of different ways, including Lambda functions. So you can use a Lambda function to define a hook, or a domain-specific language like called guard that is supported by CloudFormation. We have, again, examples of these hooks inside a registry that is publicly accessible. We will share that link at the end of the talk so you can take a look at what might be appropriate for you. Finally, let's talk about detective controls, the additional line of defense for auditing your environment and making sure nothing is violated. Detective controls are implemented as AWS config rules. Remember, they don't actively prevent any actions or changes, so they can always be enabled safely. Very often what we see customers do is before a preventive or proactive control might be enabled, they actually enable detective controls first to understand what violations might already be present in existing applications or resources within their environment, make sure that everything's fixed correctly before enabling the preventive or proactive controls, and this is done to ensure that no unintentional breakages happen if you enable the preventive or proactive controls too soon. When config is enabled in AWS config is enabled in your environment, one of the things it does is record all configuration changes that happen in your environment. So, concrete example: let's say I have an EC2 instance and I add a new tag to it. This additional tag causes a new configuration to be created, which is captured by the AWS config recorder. The configuration change is then sent to a config rule, which will then evaluate the configuration for any violations that might be present. If the configuration is valid, it will indicate as such. Otherwise, it will return that the resource in question is non-compliant with the policy it encapsulates. You can retrieve this non-compliant state either through an SDK, or through console, or you can be alerted to it through a CloudWatch event or an SNS topic. As we've discussed, there are three different kinds of these controls: preventive, proactive, detective. You can obviously implement and deploy these controls on your own, that whatever suits your needs. But one thing we'll call out is AWS actually provides a set of managed controls that are already available that you can just turn on. These controls are managed by us, and they represent the best practices that we believe make the most sense for most customers. You can discover these controls through the control catalog in Control Tower. There are over 750 controls available now, and we're always adding more. You can search for these controls within the catalog, and all of them have a consistent namespace as well as a set of consistent metadata, like the domain, like an objective, for example, encryption, or common control definitions such as encrypt data at rest. We also map these controls to a set of common compliance frameworks. Last week, we just released an update to the control catalog where we now have mappings for 10 compliance frameworks, including FedRAMP, CIS v8, and one of the NIST, a few of the NIST frameworks. I can never remember the numbers. I'm sorry, they're very long. But once you've discovered the appropriate controls in the catalog that you need, you can simply use the enablement APIs within Control Tower to deploy these at an organization unit within your organization, making it very convenient to fulfill any objectives that you might have to GRC. So quick takeaways at the end. So controls help you achieve your GRC objectives. They are really critical to achieving them. There are 3 types of controls: preventive, proactive, and detective. And finally, there are a set of managed controls that you can easily discover. And on many of these controls, we do release the source code as open source as well in the repository. Again, links at the end of this presentation. Next, I'm going to have Nivas come back and talk about data resiliency.
Data resilience at scale. So we're going to switch gears a little. Akansh talked to us about the meta governance story, Aaron about controls, and now we're going to talk about data resilience, so data aspects. The first is data has value. And you may have already heard of this phrase, data is the new oil. It's been shared with several of our AWS presentations. But the main point here is that with data, we can do and accomplish a lot of different things. Organizations are using it to build operational efficiency, improve the customer experience for products, as well as innovate with many different things. So data is extremely valuable, and it needs protection, resilience, and governance depending on the type of data. And sometimes we may tier data into different data sets: sensitive data sets, private data sets, public, and so on. The second, and this is something to keep in mind, is that data is growing, and it's growing at an exponential pace. We're adding more and more data sources to feed into our analytics, into our machine learning models, and more. So if you actually take a look at this chart, you will see that in 2010, we had 2 zettabytes, and 1 zettabyte is equivalent to 1 trillion gigabytes. So we had 2 zettabytes in 2010, and in 2028, we expect to nearly go about 200 times more. So that's a lot of data. It's very hard to visualize, but the key point here is it's exponential. So what this means then is that we really need to protect this data and build it into proper resilience standards. And that's a challenge. That's a challenge because we're working with a multi-account environment. You have multiple accounts, you have multiple teams, they all have their own applications, but how do we standardize and ensure that the data, the applications are backed up and are meeting your compliance requirements? And so we start with backup because it's one of the primary ways of meeting your data resiliency and protection goals. The first recommendation is understand your recovery time objectives and the recovery point objectives for your applications. Your applications, as shared before, are going to be different. You may have an application that's a test application that's dealing with a public data set versus an application that is in production dealing with PCI data. And it's important to review the use cases, understand what the individual RTOs and RPOs are and group the applications accordingly. The second is implement least privilege policies. And this is very similar to ensuring that you understand who has access to the data. Not everybody needs access to the PCI data sets, as an example. Third, determine your backup retention period. What do I mean by this? There's 3 types of backups: incremental, differential, and full. But with incremental, you're taking a backup since the last change. And with differential, you're taking a backup since the last full backup, and then a full backup is just everything all together. But this, again, is going to depend on your application, your use case, and the compliance requirements. 4, enable encryption strategies for the data that's being backed up. And number 5, actually, this is something that applies to everything that we do. Even the controls that we apply across our multi-account environments, validate it. So here we're talking about data policies, but it also applies to the controls that you're applying. Validate it through continuous testing and auditing, setting up reporting, and ensuring that the controls that you've applied across your environment are doing what you expect them to do. And so how do we accomplish this on AWS? The key service to do this is AWS Backup. And AWS Backup supports a variety of services. On the compute side, it supports EC2, container workloads, even VMware. You can use AWS Backup to back up on-premise VMware data to the cloud. Supports storage in the form of EFS and EBS, databases that range everything from DynamoDB, Aurora, RDS, and TimeStream, and more. So you can set up backup plans, and you can set this up across your organization, and you can set up multiple backup plans depending on your goals for each application group. The third, actually, is setting up the notifications. Notifications are very important because you need to know who's accessing your backed up data. And you can use CloudWatch, you can use CloudTrail, as well as SNS. Some customers may even set up Slack notifications. But it's important to know who's accessing the backup data. And then, of course, this works across your multi-account environment, both across organizations and control tower. You have IAM controls. And this is also important, Backup Audit Manager. This allows you to create backup reports. And it helps you answer the questions of, have I backed up all of the important resources across my environment? Have I encrypted my backup? And number 3, have I met my compliance requirements? So by setting up reports, and you can set this up on a continuous or daily or like anything that you'd like, it gives you a good report of where your backups are. Again, you can access this through the console, through the API and SDK, like several of our services. The third one is the most important and key. We have seen a lot of customers use this, but it's the tag-based approach to set up your backup policy. And so organizations may tag their applications as prod, and that will apply an appropriate backup policy to the prod-based applications. And then you can do something similar for test and so on. Now, there is a challenge that takes place here. You can do everything right. You can set up your backup policies, and it's working across the organization. It's working across all of your thousands of applications. But what if, for some unfortunate reasons, someone gets access to your management account? In that case, that entity could potentially corrupt your backup data or even delete it. And that's the risk. And so we introduced AWS Backup Logically Air-Gapped Vault. And this simply means that the backup data is within the AWS service accounts, so it's containerized from the customer's AWS accounts. And so if somebody gets access to those AWS accounts, the management account, this is still safe. And so this isolates the data using service-owned keys, ensures that the data is immutable, and also allows you to recover your data quickly using AWS RAM from AWS organizations. Now, yesterday, we actually added to this feature. And the new feature is backup integration with multi-party approval. So think of this as simply you're giving a group of individuals the ability to approve backup data retrieval actions. And so you can do this within an AWS organization's environment. And this helps because now you can set up a team of 4 or 5 individuals that have to approve a certain action before the data is retrieved from the lag data backups. Okay, so I'd like to quickly summarize the data resilience piece of things. 1, review your applications. Develop a backup strategy for each of your applications. And take advantage of the lag and the multi-party approval for your teams to provide greater governance for your data. Then, in conclusion, from Aaron's talk, we talked a lot about controls, and these are examples of SCPs, RCPs, and CloudFormation Guard rules that you can review and get started with using to build your own custom rules. The other recommendation I'd make, we would make, is take a look at AWS Control Tower. It has a whole host of managed controls that should give you a good starting point. That concludes our presentation. Thank you so much for joining us.